Good morning, students. Now today we are going to discuss the topic on tangent plane and normal to a level surface. So you have fxyz equal to c be any equation of a level surface, and r bar is equal to xi plus yj plus zk be the position vector of any point P on this level surface. And capital R bar is equal to capital Xi plus Yj plus Zk be the position vector of any current point Q on that tangent plane at P to the given surface. So PQ bar, as you know, it is nothing but the position vector of Q minus position vector of R, which is equal to R bar minus R, small r. So as you know that capital R bar is equal to Xi plus Yj plus Zk cap, and small r bar is Xi plus Yj plus Zk cap. So you just subtract these two vectors. It gives you capital X minus small x into I plus capital Y minus small y into j plus capital Z minus small z into k cap. And note that this PQ lies in the tangent plane P. So since it lies on the tangent plane P, therefore this vector PQ will be perpendicular, or will be a vector normal to delta f, that is perpendicular to the gradient of f, where del f is a vector along the normal to the surface at P, and it is perpendicular to the tangent plane at P. So as you know that if two vectors are perpendicular, a bar is two different vectors are said to be perpendicular to each other if the scalar product is equal to 0. So since this vector PQ bar is perpendicular to this del f, that is gradient of f, so we must have that the cross product, the scalar product of these two vectors. What is PQ bar? It is nothing but R bar minus small r bar dot of del f is equal to 0. Now using the scalar product, what is R bar minus small r? It is this vector. And what is del f? It is I del f del x plus j del f del y plus k del f del z is equal to 0. Or you can have here x minus small x. You take the scalar product of these two vectors. You have x minus x into del f del x plus y minus y into del f del y plus z minus z into del f del z, because I dot I gives you 1, j dot j gives you 1, k dot k gives you 1, whereas I dot j gives you 0. Similarly with others. So therefore this is the required equation of the tangent plane at P, that is x minus small x. You have to remember this formula, plus capital Y minus small y into del f del y plus capital this one into z minus small z del f del z is equal to 0 is the equation of the tangent plane and P. Now also we have, now you consider Q to be the current point on the normal. Here you have taken Q to be the current point on the tangent. Now you take P to be the current point on the normal at P, and therefore this PQ bar, which is where PQ here is the position vector of P minus position vector of R, that is R bar minus small vector R bar, is parallel to this gradient of F if P is the current point of on the normal at P. And we know that two vectors are parallel to each other if A bar cross B bar is equal to 0 vectors. Two vectors A and B are said to be parallel to each other if their cross product is equal to 0, whereas perpendicular to each other if their scalar product is equal to 0. So you have to remember these two conditions. So therefore this PQ bar is parallel to the vector gradient of f. So it means that vector R bar, since PQ bar is this, you have R bar minus R bar cross of del f must be equal to 0 vector, and this is nothing but the vector equation of the normal at P, of the normal at P to the given surface. Now this same equation, now convert it to Cartesian form. So you have these two vectors R bar minus small r bar, and this gradient I del f del x will be parallel if one is a scalar multiple of the others. That is, if x minus small x into I plus y minus small y into j plus z minus small z into k is equal to P times of del f. And that P times of del f here is nothing but I into del f del x plus j into del f del y plus k into del f del z. Now equating the coefficients of I, j, k, we get by equating the coefficient where p here is any scalar quantity. So by equating the coefficient of I, j, k, you have x minus small x is equal to p, y minus small y is equal to p times of this, that is p into del f del y, and coefficient of k, by comparing it with this, you have z minus small z is equal to p times of del f del z. So if you take, now you divide through this one by del f del x, so what you will get p here also, if you divide it by del f del y, you will get p. Here again, if you divide it by del f del z, you will get p. So this shows that this equation x minus x by del f del x is same as y minus small y by del f del y is equal to z minus small z by del f del z, which is equal to scalar quantity p. And this is the equation of the normal to the surface in Cartesian form. This is in Cartesian, so you have to remember this formula while solving the problems. Now let us see this problem, how to find the equation. Find the tangent, equation of the tangent and normal to the surface, given surface, twice x square minus 3xy minus 4x is equal to 7 at the point 1, minus 1 and 2. So how we solve it? The equation here fxy, equation of the surface is given fxyz is equivalent to 2x square minus 3xy minus 4x equal to 7. So therefore del f, that is gradient of f here, is equal to I into del x plus j into del y plus k into del z of f here. And you differentiate this is I into del x of twice x z square minus 3xy minus 4x, and then plus j into del y of this same function, that is 2x z square minus 3xy minus 4x, and then plus k cap into del z of 2x z square minus 3xy minus 4x. So you differentiate this partially with respect to x, y and z respectively. Here in this case, keeping z and y as constant, what you get is this I into twice z square minus 3x minus 3y plus j cap. Here you will get only minus 3x plus, here keeping x and z y as constant, you will get plus k cap into 4x z only. The rest, the partial derivatives of this will give you 0. So you take the gradient of f. So this implies that del f at the point 1 minus 1 and 2 will be equal to I cap into this one 2 into what is set here, it is 2 square minus 3 into minus 1 minus 4 into 1, and then plus j into minus 3 into 1 plus k cap into 4 into 1 into 2. So this is nothing but 8 plus 3 minus 4 gives you 7 I cap, and then minus 3j, and then plus 8k cap. So this is the gradient of f. Now the position vector of this point P, position vector of point 1 minus 1 2, you take it r bar is equal to I minus j plus 2k cap, and capital R bar is equal to xi plus yj plus zk cap is the position vector of any current point x, y, z on the tangent plane here, on plane at the point P here, whose coordinate is 1 minus 1 2, then the vector this one r bar minus small r bar will be perpendicular to gradient of f. So if it is perpendicular to the gradient of f, As you can see here, del f is this. So you have position vector of this point P, this is P, is given to be this, and r bar is any position vector of the current point Q on the tangent plane at the point P. Therefore, r bar minus small r is perpendicular to the gradient of f. So for that, what we have here is r bar minus small r bar dot of del f at the point 1 minus 1 2 will be equal to 0. But what is capital R bar here? It is x minus, that is x minus 1 plus y minus of minus 1 will give you y plus 1. So x minus 1 into I plus y plus 1 into j plus this one z minus 2 into k cap is into dot of, this is dot of del f at the point 1 1 and minus 1 is nothing but 7i minus 3j plus 8k cap is equal to 0. So from here you take the scalar product of these two vectors, what you get is 7 times of, this implies that 7 times of x minus 1 minus 3 times of y plus 1 plus 8 times of z minus 2 is equal to 0. Now the equation of the normal in Cartesian, this is the required equation of the tangent plane and to the given surface fx, y, z equal to c. Now the equation of the normal to the surface, equation of the normal to the surface fx, y, z, that is this one twice xz square minus 3xy minus 4x equal to 7 at the point 1 p. Here you consider this point p as 1 minus 1 and 2 is x minus, use that formula, x minus small x here is 1 divided by del f del x is equal to y minus of minus 1 divided by del f del y is equal to z minus small 2, this 2, z minus 2 divided by del f del z, and here that is x minus 1 divided by del f del x. If you replace here, as you can see here, it is at the point, it is del f del x here, it is at the point 1 minus 1 minus 2, it is 7, del f del y at the point this one, it is minus 3, and del f del z at the point 1 minus 2 is nothing but 8 here. So you just replace it there. So by 7 here you have y plus 1 divided by minus 3 is equal to z minus 2 divided by 8. So this is the equation of the normal to the surface. Whereas this one, it is nothing but the equation of the tangent, equation of the tangent to the given surface. I hope it is clear to you.